Hello everyone, my name is Ashwarya. I am going to teach you design and analysis of algorithms. First of all, we need to understand that what is the exact problem solving is. If we are looking for some problem solutions, then we need to understand that which solution is better than other one. So if you have multiple solutions to any problem, we need to understand that which is the best one. And this is the field computer science is one of the fields that will lead to understand the problem, what are the techniques that you can use for problem solving, and what are the solutions, multiple solutions that you are having, and which one is better than among all those. So algorithm basically makes you understand that it is a step by step process of, or you can even say it as it's a finite step of instructions that will lead to some solution to a problem. So we have specifically mentioned here that it's a finite processes. It's a finite steps to solve any problem. Algorithms can also be said as solutions to a problem, and it is one of the most important field of computer science that need to be understand, because if you want to solve any problem, we need to understand what should be the algorithm respective to that particular problem. Why we are studying this particular topic and why we are studying this particular field is that being a computer science or computer scientist, we need to understand that if a problem is having multiple solutions, then we need to figure out that which solution among all those solutions is better, which solution is best out of all those, with the respective of their time, with respective of their space, with respective of their line of codes and all those things. So we need to understand which is the better solution among all the solutions. If we are going to understand what exactly the problem solving main steps are, so first of all we need to understand what the problem definition is. We need to understand that what exactly the definition of problem that is being asked is. Then we need to understand what are the algorithm designs. These are some predefined algorithm designing techniques, or you can even say it as algorithm specifications. For example, divide and conquer, for example, greedy methods. Then you can have dynamic programming. Then you can have backtracking and branch and bound. So these are some designing techniques that are already predefined designing techniques. You can even create of your own also. That will lead to some solutions to a problem. Next step, you need to analyze that if you are writing a solution, if you are writing multiple solutions to same problem, then you need to understand what should be the best one. On the basis of the analysis, you need to analyze the algorithm, you need to analyze the solution, and then final implementation will be done of the solution which is best out of all. Then testing, which is also a continuous step that is to be taking care in problem solving, and last one is maintenance. So in this particular course we are going to discuss about how we can analyze the different solutions to a problem. That means we are going to understand what is the analysis of an algorithm, along with how we can design the algorithm for a problem. So the subject will be, or course will be, designing and analysis. Both the things we are going to do. We are going to analyze multiple solutions and figuring out which is the best one, and we are designing the algorithm to a respective problem. So if I talk about the first step, which is problem definition, let's discuss it. Problem definition means that what exactly the time, that is the requirements of your problem, what are the space that is needed to be, what is the speed of the system that is need to be taken care. So you need to understand all these parameters before executing, before writing an algorithm to a problem. Okay, before writing, or while you are writing a problem solutions, while you are writing the algorithm to a problem, you need to take care of the uh, time complexities. Means analysis which is being done will be based on your time complexities. Analysis is specifically taking care of time, which is CPU time. Means if you are executing any program on i3, that will be slower than if you are executing the same program on i5, and so on. So time will be directly proportional to what type of processor you are using. And the another one is your space. Space is your, while we are executing any problem, that will be taking space from your main memory. So space is the main memory space. So you have to You have to take care of time as well as the space. So time will be the priority thing. So we have to first analyze the solutions on the basis of their time complexity. Now time complexity can be of different types. You can say worst case. Worst case means upper bound. You can even say it as upper bound. Worst case, you can even say it as maximum time that is taking by an algorithm. And average is your and approximate time of between worst and best case. Your algorithm should be efficient. So there are some goodness that need to be mentioned in your algorithm. Now, what the definition that you can write out of algorithm is, I have already told you that this is a step-by-step instruction. So this is a set of instructions to solve a problem. Now, its characteristics that if you are writing a problem, there should always be zero or more quantities are externally supplied. Means if you are writing any program, there can be zero input as well as more than that particular more than zero. Definiteness should be there. Means each instruction that you are writing in an algorithm should be clear and unambiguous. It should be clear and unambiguous. Finiteness should be there, that you have to write the finite number of steps. After finite number of steps, your algorithm should stop, should terminate. That should not go in infinite loop. Fourth one is effectiveness, that your instruction should be primitive and feasible. Means if you are writing an instruction, that instruction should contribute something to your algorithm. It should not be the best or it should not be like repeated one. Last is your output. If you are writing any problem solution, then you should come out with an output, because if you are not getting any output, there is no means of writing an algorithm to a solution. So these are the major 5 characteristics that has to be keep in mind while you are writing any algorithm to a problem. Now let's take an example, a simple example. I told you that it's a combination of sequence of finite steps. You can say it a combination of sequence of finite steps. It's a step-by-step process to solve a problems. So these both are same things. So let's say I'm writing algorithm for addition of two numbers. So I have written the algorithm for addition of two numbers. Like I'm taking two numbers, I'm just adding a and b, which are the numbers, and I'm storing that particular in C. Means I'm doing something like this: A plus B is equals to C, and now I'm printing C. So this is simple algorithm for addition of two numbers. Let's see, this particular algorithm is taking, if you talk about all the 5 characteristics, let's talk about the first one, which is input. So input for this algorithm is A comma B. Means you have zero or more than particular zero or more inputs. So I have two inputs in this particular problem. Second characteristic was your definiteness, that if you see every instruction of this algorithm, you can easily see that there is no ambiguous statement, there is all clear statements. Means if you are saying take two numbers, that means it is specifically saying that you have to take two numbers. Third one is your let's say finiteness. Then that addition of two numbers is terminating after 3 steps. So you are writing only 3 steps, which is a finite number. Next is your effectiveness, that there is no step in this particular algorithm which is not feasible, which is not relevant to the problem. You are right. If you are taking two numbers, and these are very important steps. If you are adding them and storing in C, this is also important step. And finally, you are printing the output. That is also an important step. Last one is that if you are writing a solution, if you are writing an algorithm to any problem, you need to come out with a solution. You need to come out with an output. So output is also there, which is C. So all the 5 characteristics is fulfilled with this particular example, addition of two numbers. So this is how you can write a algorithm to simple problems as well as to complex problems. Now there are some more points that need to be taken care. That algorithm is a procedure to accomplish a specific task. It is an idea behind any reasonable computer program. Algorithm must solve a general or well-defined, well-specified problems, and all those things that you have to take care of. That whether you are solving any problem, you should come out with an output. You should have the best algorithm out of all the algorithms. You should analyze your algorithm on the basis of time and space and other things. So this is what algorithm is. Now, algorithm, what is the difference between algorithm as well as the term which is very common, that is programs. Algorithm is a method. You can even say it as a step-by-step instructions to solve a problem. But program is program is your simply the code that you are writing to execute on your computers. It's simply a code that you are writing to execute on your computer. So algorithm is step-by-step instructions to solve a problem, and program is that you are writing to execute the code that you are writing to execute on your systems. And you can even see one more term you can come across with term also, this which is process. Process is program under execution. When your program is running and it is using CPU and main memory, then that particular program will be called as process. Now there are some algorithm properties that it must be correct, algorithm should be correct, and there should be series of concrete steps. I told you that there should be finite steps and there should be no ambiguity. All the steps should be unambiguous, finite steps hone chahiye, and it has to be terminate, it has to come out with some kind of output. So algorithm problem solving steps, I told you these are some these steps which are the extended version of the previous step that I have discussed. That first of all you have to understand the problem, then you need to understand which designing technique you can apply. I told you these are the 5 important designing technique that we are going to discuss. Then you can draw the flow charts, then you can test, you can implement your algorithm, and finally you can analyze on the basis of time and space complexity. So this is all about the introduction to what is algorithm is, how you can write the algorithm, what are the characteristics of algorithms, and what different designing techniques that is to be keep in mind while you are designing any algorithm. So thank you so much. In the next class, we'll be discussing about how we can analyze the algorithm on the basis of its time complexity as well as on the space complexity. So thank you so much.